Hi there, I have a nice trigonometric problem which involves almost all of the trigonometric functions that we know: sine x, cosine x, tangent, cotangent, secant, and cosecant. And we are supposed to find this function's minimum. And here, of course, it's minimum because, well, tangent, cotangent, none of these are bounded. And also, of course, we have absolute value because, I mean, if we didn't, it would be just minus infinity. And we just want to be as close as possible to 0. Also, well, actually, the first thing I thought, the answer is very trivial. And it would be when x is just equal to, well, it's not plus pi over 4, but minus pi over 4. Well, this makes a lot of sense because I'm trying to just minimize all of them, because this is just reciprocal of this one, and this is not reciprocal of that one, but this is just reciprocal with this one, and this is with this one. So actually, just if, like, for example, sine x is very small, this will be very big. So I don't want that. I kind of want all of them to be something nice. And I actually, if I pick x is equal to minus pi over 4, these two will just cancel. And similarly, these two will also just cancel. And this will be minus 1. This is minus 1. So it will just be minus 2, which is going to give me 2. This is actually close, but we can do better than this. Okay, so this is first guess, but we can do better than this. Okay, I mean, it's not greater or equal than 2. Yeah, minimum of it is less or equal than 2. Okay, let's say mean. Or let's just don't write. Anyways, so we can do better than this. Okay, so I'm just gonna, I mean, call this fx. Okay, I'm gonna say fx is equal to, so I'm just gonna write this thing. I'm gonna try to find minimum of absolute value of fx. Okay, so I have sine x, cosine x, plus, so tangent is sine over cosine, this is cosine over sine. If I add them and multiply this by sine, this by cosine, so I'm just gonna get 1 at the top. It's sine squared plus cosine squared over sine x, cosine x, plus, and this is 1 over cosine, 1 over sine. So I'm just gonna get sine x, cosine x, over, so it will just be, again, sine x, cosine x. Okay, cool. So here, if I look, well, everything is in terms of sine x plus cosine x, or sine x times cosine x. So I'm gonna try to just express them in terms of each other. And the first thing you may think, oh, if I just say, call this thing a, and a squared is just gonna be sine squared plus cosine squared, which is 1, plus 2 times this thing, 2 sine cosine, 2 sine x cosine x. This is actually fine. You can try to just, you know, call this a, and just, you know, take derivative and try to find critical points. Well, it will be a bit high degree polynomial. It will be like 4th degree, and it won't be so easy to find roots. So this is fine. You can try to work with that, but we can do better than that. Okay, so I'm gonna try to express them in terms of each other. Okay, so what I know is that sine x times cosine x is just sine 2x over 2, right? This is almost sine 2x, but it's half of it. So I will try to write this one like that, maybe like sine 2x or sine x. So basically, so we are gonna do a trick here: sine x plus cosine x. This is a very nice trick. So what we can do is, actually, I can just multiply it by 1 over square root of 2, and also multiply by square root of 2. So nothing changed. I didn't want to write again sine x plus cosine x. So this is gonna be, so I'm gonna leave this one alone, because I know that 1 over square root of 2 is equal to cosine of pi over 4, but also sine of pi over 4. So I can actually just write this thing as, so here I can either choose sine pi over 4, sine x, plus cosine pi over 4, cosine x. And like I said, you can swap this cosine pi over 4 and sine pi over 4. It won't matter, except, I mean, of course, you will get a bit different answer, because if you look at it like this, this is cosine subtract formula. So this is just cosine pi over 4 minus x And if you actually wanted to swap them, you would get square root of 2. So it would be just sine times cos, cosine times sine. This is just sine addition formula. So it would just be sine x plus pi over 4. You can just try to see which one works better for you. So let's go with this one, okay? So now I'm going to make a substitution, and I'm going to call this thing y, okay? Let's call this thing y. And so my goal is to get, is this something close to that? Can I mean, represent them in terms of each other, okay? So I have pi over 4 minus y minus x is equal to y. So I'm just going to multiply both sides by 2 because I want sine 2x, okay? So I'm just going to separate the x and multiply by 2. So I'm going to get 2x is equal to pi over 2 minus 2y. And now if I get sine of both sides, sine 2x. So all of these are parentheses, okay? I don't write it. So this is going to be sine of pi over 2 minus 2y. And this is just equal to cosine of 2y. Well, here you may think like, oh, is this always true? Is it when 2y is between 0 and pi over 2? Well, this is actually always true. You can just expand this with sine subtraction formula, and you will see that this is always equal to cosine 2y. Okay, it's simple. But I also had over 2. Okay, over 2. So I got this thing. Okay, so that thing. So sine 2x is just cosine 2y, okay? And now, so well, I know that sine x, so here what I found was sine x plus cosine x is equal to just square root of 2 cosine y. And for sine x times cosine x, I said it's just cosine 2y over 2. So I said sine x cosine x is just so it's just cosine 2y over 2. And now, so can I write cosine 2y in terms of cosine y? Yeah, of course, yeah. So for example, if I call this whole thing a, okay, because I know that cosine 2y has square of this thing, so the square root of 2 won't be a problem. So I know that cosine 2y is just 2 cosine squared y minus 1. So I'm gonna get so cosine y is equal to a over square root of 2. So this will be a squared over 2, and 2's will cancel. So this is just a squared minus 1. Okay, so this thing now is just a squared minus 1 over 2, because I also have this over 2. Okay, so now I wrote both of them kind of simple form. Okay, they are both kind of simple. And now, so let's try to just substitute them all back in. So let's go here. So I said I have sine x plus cosine x, which is a. So now, well, also here I said fx, but now we turned them into a. So I can also say, if I want, I can say f of a, okay, or g of a. It doesn't matter. So let's just say it's equal to, so I have this is a plus, and this is, so I can just add them at the top, okay? So this is sine x plus cosine x is a, and this is 1 over, and this thing is just a squared minus 1 over 2. So I'm just gonna flip it. This is a squared minus 1 and times 2. Okay, let's put it here. And well, this is just difference of 2 squares. Now this is a minus 1 times a plus 1. So if a is not equal to minus 1, I can simplify them, because it's not, it wouldn't be 0 over 0. So if a is not equal to 0, okay, this is equal to a plus, so I have 2 over a minus 1. Okay, cool. And also, of course, a is not equal to 1 also. I mean, because it's at the denominator. Or even here, I could just say that. But anyway, so a is not equal to minus 1 over 1. Okay. So now, so I found that FA, okay, let's call this thing FA or GA, doesn't matter. And I found it's something kind of simple, okay? So let's rewrite it. FA is equal to A plus 2 over A minus 1. Here, you can just again do the derivative test, and you can just take derivative, and this time it's much nicer, and you can do it, but we will again do a trick, okay? So we will just solve it a bit nicer, and we're gonna use the fact that so this A is, if I multiply these two, which means I'm going to use AMGM inequality, okay? Because now if I say this thing is just A minus 1, okay, so I subtracted 1 and added 1 again, so okay, this is just extra term. I know that GM, which is geometric equality, okay, geometric mean, is always less or equal than AM, which is arithmetic mean, okay? And so GM is for two value x and y. I know that this is just xy in square root, and this is always less or equal than AM is just x plus y over 2. And why can I use this? Because I want to see that absolute value of this thing is greater or equal than something, right? Because I want minimum of it. And indeed, I have addition of some stuff, and I'm gonna see that is it greater or equal than something. And I also know that when the inequality holds when x and y is equal to same, okay? If x is equal to y, this will be equal, okay? But here I'm gonna actually have two cases, because I need absolute value of this thing. And so basically, I don't know if it's positive or negative. And when this thing will just be positive, is that, so if I think A minus 1, and so A minus 1 has just the same sign with this thing, because it's also just same, it's just flipped. And so maybe I can separate it. If A minus 1 is greater than 0, when this is positive, so let's see what is FA now. So this is positive, this is positive, this is of course positive. So everything is positive, and FA is going to be equal to this thing, okay? A minus 1 plus 2 over A minus 1. And so I have also plus 1. So this is greater or equal than. I won't touch this one, okay? This is just same. And I'm going to do the AMGM inequality here. So I know that addition of two stuff. So here also I can just rewrite it as 2 times xy, because I only have here addition of two stuff. So if I multiply these two, I'm just going to get 2. So this thing is actually greater or equal than 2 times in square root their multiplication, which is just 2. So this is greater or equal than 2 square root of 2. So this is for A is greater than 1. Okay. And so for negatives, if A minus 1 is less than 0, and here actually, well, I won't go into details of this part. And so you can think like x plus 1 over x, okay? If x is negative, I mean, this thing is just, if this thing is negative, so if you put x is equal to 1, okay, this will be equal to 2. And if you put minus 1, this will be equal to minus 2. And if you change x values, this will just be even less than minus 2. So actually, if A is less than 1, if A minus 1 is negative, okay, if A minus 1 is negative, then this whole thing will also be negative, okay, because this one is kind of smaller than that thing. So I'm going to have that FA is equal to, so this thing will just be negative, so which means it will just be minus, okay? So minus a plus 1, let's say 1 minus a, minus 2 over, or let's say plus 1 minus a, and minus 1. Okay, so greater or equal then. I'm again just keeping this minus 1. And so I will again just use the same thing. If I multiply these two, I'm just going to get 2. So this is greater or equal than 2 times that thing. 2 times square root of 2. So this is when a is less than 1. Also, I could put inequalities here. I mean, it just doesn't matter. If it's 0, both of them are 0. So I can just put it on one of them. It doesn't matter. Okay, all of them are good. So what did I find? Actually, I'm almost done here, because I found that for some a bigger than 1, this is gonna be true, and for some a less than 1, this is gonna be true. And of course, this thing is just less than this thing, right? Because I mean, it's just minus. There's 2 difference here, and so I'm gonna see if I can achieve this value. And like I said, when I was talking about this inequality, I know that this holds if and only if x is equal to y. So I want this inequality to hold, because this value, 2 square root of 2 minus 1, is the minimum value of this thing can get. And I want to find minimum of this function, and I want to know, can this be equal to that thing? And like I said, so it's equal when this thing is equal to this thing. So 1 minus a is equal to 2 over 1 minus a. So it's just a minus 1 squared, a squared minus 2a, plus 1 minus 2, so it's going to be minus 1, equal to 0. And if I do this, so it will be just half of this, 1 over 2, sorry, it's just 1, plus minus this thing squared, 1 plus 1, 2. And here, so is it going to be plus or minus? Well, if I remember what was a was just square root of 2 cosine y, right? And I know that cosine y is just between minus 1 and 1. So this is between minus square root of 2 and square root of 2. And 1 plus square root of 2 is just bigger than square root of 2. So this is just less than 1 plus square root of 2. So a cannot be here. I mean, a cannot be equal to this. Okay, a is less than square root of 2. So from here, I know that if I pick a is equal to 1 minus square root of 2, I'm going to have that, so a is 1 minus square root of 2. Then this equality will hold. This will be equal to that. So AMGM inequality will be just equality. And this, our function, will be equal to 2 square root of 2 minus 1. And I also found that this is the possible minimum I can get, and I learned that I can get it if I pick a is equal to 1 minus square root of 2. So that's it. Actually, our minimum, which is the answer, is just 2 square root of 2 minus 1. Also, this thing is equal to what? I calculated it, but I can see where did I write. So this is like 1.8 something. Okay. And like we said in the beginning, I thought that, oh, maybe the answer is 2. So 2 is, of course, yeah, this thing is just less than 2. So this is actually a better answer. And this is, I mean, it's just the best answer. Also here, you don't have to find a. We directly found the minimum. But if you wanted to find a, we can also just find it. So we said a is equal to this thing. Okay. So I want to first find y, and then I need x. So from here, I can say that a over square root of 2. So a is just 1 minus square root of 2. If I divide it by square root of 2 and take arc cosine of both sides, arc cosine, which is inverse of cosine. So this is equal to y. And I also said that y was pi over 4 minus x. So from here, if I just swap x and this thing, so x is just going to be pi over 4 minus this thing. Okay, I don't want to write it, arc cosine. This thing. So this is the best x we can get. And so in the beginning, I said maybe minus pi over 4, but which is very surprising and of course impossible to guess in the beginning that So this is the best x value we can get. Okay, and that's the end of it.